Rahim. Welcome to the class of Irrigation Engineering. And today is 11th of March. At the moment, how many students with me? 38 students are with me. One student 202 is requesting to add him, but I don't know which section he wants me to add him. 202 is in what section? Anybody?
D section.
Section D?
Sir, D section. D
Okay.
section, sir.
Okay, then give me a minute. I have to add him. In team, in section D, add a member. So he has been added now. Okay. So I have put the link on WhatsApp also. Started the recording, so these are the quick check. I have shared my screen also now. And before other people join us, let us have a quick review what we have gone through the subject of irrigation up till now. We have focused on different importance of irrigation. We have tried to inform you, and we have linked this irrigation with the economy of the country, with the need of the society, with the need of the population living in a country, with respect to their food requirement and with respect to their fiber requirement and with respect to their what we call it wearing clothes requirements. So we need agriculture. Agriculture can survive if sufficient water is available. If sufficient water naturally is not available, we have to go towards irrigation, which we define as artificial application of the water. We have informed you why irrigation is required in a systematic manner. Main reason is for sustained growth of agriculture, and why we need it. Reason is uh, ununiform or non-uniform rainfall with respect to time and with respect to location. We have told you that because irrigation is provision of water and provision of water, क्या कहते हैं? Usman Rafi is waiting in the lobby, and why he is waiting in the lobby? Admit him, and I have to, I think, change the setting. Manage permission. So people in the organization. So Usman Rafi is out of the organization. So I am hoping that anyone can join. Don't have to go to lobby again. So we have informed you that the irrigation, which depends upon water, and water is not available in unlimited quantity. It has a limited quantity. So we have to be careful while using water for any purpose, not only for agriculture purpose. We have also informed during the discussion that there are three main stakeholders. Ali Usama, आपका mic on है. We have also told you that there are three main sectors in addition to the fourth section of environment. There are three main sectors which are user of water, and those sectors are agriculture, urban water supply, and the third one is industrial sector. So each sector need to look into it with respect to careful use of water, so that water should not be wasted. In urban supply sector, you can see our habits of using water without considering its value for the person who is short of water. We keep our taps open while we are doing some other works. We keep our lawn pipes or lawn hose, keep them open without taking care that we are using the fresh water, which is not easily available to a big population of the world. So we should be careful in our daily life. We should be careful as a nation also. We should not be losing water. Wherever possible, we have to conserve water. Where we have to uh, reduce our demands, because unlimited supply of water is not possible. There is a limited supply of water. You were informed about the habits of using water all across the world. For example, can I take a minute to receive a call? Okay, sorry for disturbance. There was a call from friend. Okay. So we have told you the water used by different sector in high income countries, and we have also informed that as compared to these high income countries, the water utilization in Pakistan is much different from the behavior of the high income countries. Anybody will tell me how much percentage of the total water available in Pakistan we are using for agriculture? कोई बताएगा मुझे? 59% we are saying this is water use by industries in high income countries, and 30% is the water used by agriculture in high income countries, while the global average is that 69% is used by agriculture. What is the use of water by agriculture in Pakistan? क्या है वो?
89
Yeah,
or
89,
95%.
95%. मेरे ख्याल में 95% is what we quote.
95%.
The 95% is the right value, and the rest 5% nearly equally shared by industry and by urban water supply. So 95 as compared to global average is bad, but as compared to high income countries average, which are only allocating 30% of the water, is also very bad. So we when we will be shifting towards high income countries, then our this use of the water, this allocation will also be changing, and then there will be stress on irrigation engineers and agriculture engineers that they will have to give more product, but the allocation of the water will be less. So we have to go towards the high efficiency irrigation system then. So that is the way, and that is the future we have to look towards, because more supply of water is um, adding water into the system is difficult. We can add water into the system through construction of reservoirs, through construction of groundwater tubes, but it is becoming difficult, and there are more problems with it. So we have to go towards conservation also, and we have to look for some innovative ways of getting the more product out of a unit quantity of water we use. So those were the messages conveyed to you in last 2 weeks, and you were informed about merits and demerits of irrigation. Historically, a small review was carried out that informed you that irrigation came into existence once agriculture was practiced. once agriculture was practiced, and after that, when they found that agriculture cannot sustain without nature, without application of the water, then they go toward irrigation. So when they thought about irrigation, then they had to divert water, and then they had to make the canals. And so all those historical findings, which tells us that some civilization have stopped the river and stored the water and diverted it into the canal, we consider that that is an way towards going towards irrigation system. So those historical facts, that where was the first dam constructed, who were using the canals, that have been informed to you. And we have found that old civilization like Egyptian civilization, Mesopotamian civilization, Indus Valley civilization, and civilization in China and other countries, they had started using method of irrigation for as old as 4,000 years from now. We have found evidence of using Carrez irrigation system or Kanat irrigation system as old as 700 BC, about 2700 year ago, 2700 years from now, 700 BC. And you have been informed that people were using canals and dams for diverting of the water. Uh, Canals and dams were built as old as 4,500 years ago. We have found some writings which show that before Christ, about 1,000 years ago, before Christ, about 3,000 from now, people had writings which were showing the rights of water allocated to different user of water. There were rules how to resolve the conflicts based upon the water. If a conflict arose because of the water, how to resolve it. There were rules which showed the penalties imposed on the person who left bank of the river, bank of the canal open, and because of that opening, some area was flooded. So if somebody have shown negligence with respect to application of the water, and because of his negligence, if some area was flooded, there were rules which penalize the person who have done this negligence. So such rules have been found as old as 3,000 years from now. So that show that the infrastructure for irrigation was developed 4,000 years ago. Rules and regulations for supplying water and resolving the conflict regarding water were also developed in old civilization. And this modern civilization, we say that, which we are seeing now, has been started in 19th century. In 1800 something, we see the construction of the large canals in Indo-Pakistan, 1836, something like that. So that was informed to you. A very good and water conserving system which have the least losses of evaporation is this Kanat irrigation system, which use an underground tunnels to link the aquifer with the water demand area. So aquifer was connected with the land where they have to apply the water with the help of the tunnel, which was constructed by physically digging it, and then they used to clean it, they used to maintain it with the help of access points, which they call it as vertical shaft. So they use this vertical shaft to access this and to make it clean and make it maintain at its desired shape. Such kind of evidence is 100, 200-year old, can be found even current day in village environment. You can see this, we call it as a Persian well, using the animal power to lift the water from the wells in which the water is at the lower level. So they lift the water. So now most of them have been replaced with the mechanical power supplied wells and electric power supplied wells, which we call as tube wells, or we call them as wells which are powered with the diesel engine. We call them as a Peter engine. People have lifted water with the human power using lever concept, and they used to call it as a shadaf in the freeze in the old historical pictures. We have seen the people who are lifting the water to irrigate the gardens and irrigate the surrounding land. Today we have to tell you different components of irrigation whenever there will be an irrigation system. So it will be consisting of three, four main components. Uh, Before that, if I go towards the types of irrigation, if I tell you, mainly the irrigation can be divided into two kinds. One we say as a surface irrigation, and second one we say as a lift irrigation. The surface irrigation, we can give it another name as gravity irrigation. So we can divide the irrigation method of irrigation or irrigation infrastructure into two kinds. One we call as gravity irrigation system, and one we call as the lift irrigation system. In gravity irrigation system, the gravitational force, the force of gravity, that make the water run through the canals. In gravity irrigation system, the gravitational force or the pull of the earth that makes the water run in the canal. So that gravitational force come in is available all the time. We know gravity is there all the time, but it make water start running when the topography or when the channel has slope in one direction. If the channel is horizontal or if the land is horizontal, then water don't start moving because gravity is only pulling it downward. If the surface is horizontal, gravity is always there, so it is being applied on that water also, which is standing on horizontal plane. So it will be pulling downward only, so it will not start moving. So when a place has a certain angle, so then this gravity pull can be divided into two components. The force of the gravity can be divided into two components. One component parallel to land surface and one component perpendicular to the land surface. So that perpendicular to the land surface component of the gravitational force that does not help it move, but the force component, gravitational force component, which is parallel to the land, so that make it moving in the direction of the slope. So gravitational force is being utilized efficiently to move the water in the canals. So that is why all our gravitational irrigation system have the canals in which the head of the canal or the start of the canal is at higher elevation, and it goes towards the area which is at a relatively lower elevation. So this difference of elevation provides the slope. Slope comes from the difference of elevation. So our gravitational irrigation system is utilizing gravitational force to move the water, to convey the water from source of the water to the place where we need to apply that water. As compared to that, lift irrigation system, we use some external force other than the gravity, and we have to lift the water against the gravity. So for lifting the water against the gravity, we need some external force. That external force can come from a person, from a humankind, when we lift the bucket, or we use the shadaf to lift the water. So that is a human force we are using it, or we use the bulls or ox to rotate the Persian well to lift the water, or we use these engines, diesel engines or petrol engines to rotate our pumps. So that is coming from what we call it uh, oil, or what we call it एनर्जी सोर्स, इसको क्या कहते हैं, एक होता है रिन्यूएबल एनर्जी. सो दीज आर द मिनरल्स which we are using for producing the energy or for giving the energy, or we are using the electrical force in the shape of the electric connection over there, which rotates the motor, and that motor rotates then the pumps. So some external force is required in case of the lift irrigation system. So once water is lifted to a sufficient elevation, then we start the gravitational system afterward. Or up till the point of application. If we use the pipe system to supply the water, then it is the pump which is supplying, it is that engine that is supplying the energy. So this component of irrigation is more focused on the irrigation system of first kind that we call as the gravitational irrigation system. So in this kind of irrigation system, four components we need. One we call as the storage and diversion, which will supply the water. Second system or part of the system we call it as that structure which will convey water from one location to the other location. And the third component, which is sometimes a kind of soft component. These two things are hardware. So this distribution and application of irrigation water requires some rules and regulations so that the water can be efficiently divided between the users, and we should have an efficient system. So this includes distribution and application of irrigation system requires some rules and regulations. And a fourth component we need, we call it as a drainage system, which must be there when an irrigation system is supplied. Irrigation provides water to an area. Drainage evacuates the excess water from an area. You may see a canal looks similar to a drain. Hydraulically, they are similar. They are moving water from one place to other place. One canal and one drain seems to be similar, but their purpose are different. Canal is supplying good quality water for utilization in an area, while the drain is usually taking out the bad quality water from an area. Especially in case of urban drains, their quality is very poor. But if we continue with the drains, small drains joins together to make a big drain. Big drains ultimately go to the river. So theoretically or strictly speaking, we can say that river is also a kind of drain which is taking the water from a watershed area and taking it out of that area. So river is a kind of big drain, but because it is containing much water from the rainfall, so its quality is not as bad as the drain in the urban environment, because drain in the urban environment is usually having sewage water coming out of the houses, water coming out of the industry. It has in the during only storm season, during only the monsoon season, these drains also run with the storm water, but most of the time it is draining out the sewage water. So hydraulically, river is a kind of big drain. Its quality is relatively better because the water contained in it, much is coming from the glacier melt, from the rainfall, from the what we call it, groundwater flows. So four components, I again emphasize: one, source of the water; one, conveying infrastructure; some rules and regulation for distribution of water; and a campaign drainage system in that area. Previously, a few decades ago, we did not have the drainage system, so we faced the problem of water logging. Storage and diversion. Please tell me if I have already covered this, because I'll forget that if I have covered it or not. Anybody, CR, if we have covered these slides or not. Who is with me? Roll number 11, 2016 Civil 11. Please unmute your mic.
Yes, sir.
Can you tell me if we have covered this component of irrigation system in previous lecture or not?
Sir, I was not there in previous lectures, so I
Very
won't know.
nice. Very nice. Roll number 17, 11. 16, 11 was not there. 17 के 11. 16 का 200 तो सीनियर होगा. 17 के रोल नंबर 16. गुड
सर नहीं
मॉर्निंग.
पढ़े थे।
अच्छा.
यस सर.
200 कह रहे नहीं पढ़ा. और कौन सा यस सर है? 16 क्या हाल है आपके?
अल्लाह का शुक्र ठीक सर.
अच्छा. और बैठे हुए कहाँ पे हो?
सर मैं हॉस्टल रूम में अपने.
Very good. That's a final error. Chalo. So these components, I have been informed we have not covered it. So because I think day before yesterday I have taken this lecture for B and C, and I am mixing that. Might be I have covered this for you also. Storage or diversion component can be either a storage reservoir made with a dam. Dam is a barrier across the river. डैम की जो डेफिनेशन है दैट इज अ बैरियर or an obstruction across the river. Usually it is made for storage of water, and purpose of storage can be different. It can be for irrigation, it can be for hydropower, it can be for only recreation purpose. So dams are the barriers which we construct to obstruct water and to store water to create a reservoir on the upstream side, while the headworks or barrages or weirs, these are kind of small barrier, small dams, usually only constructed to divert water into the canal, not for storage purpose. These headworks, barrages, and weirs are usually they are similar to the dam, but of low height. So sometimes we call these headworks, barrages, weirs. In some countries, these are called as low head dams. Usually they don't have a storage capacity, and heading up or increasing of the water is the purpose for construction of weir or barrage or headworks. So we increase the water level by obstructing the river, and when water level is increased to few meters, few feet, then we divert that water into the canal, and then that canal take it to the area where we want to use that water. uh, so there is small difference between headworks and barrages. Usually we use these things interchangeably. We call Marala headworks, it's the same headwork we call as Marala barrage also. We call Baloki headworks, same Baloki headwork we call as Baloki barrage. But strictly speaking, that part of the headwork which is obstructing water and have gates on it, that we call as the barrage component of the headwork, and all the component constructed over there for heading up of the water, so those we call as the headworks. Headworks contain barrage in itself. Headwork contains a head regulator in itself. Headwork contain the guide bank and the marginal one and other components of required for heading up of the water. So headwork is a group of all the infrastructure which we construct for heading up of the water. And out of those component, one component which is across the river to head up the water, one component is across the river. So that is called weir. If that weir have been installed with the gates on it, then we say that this is barrage. And barrage plus other things like head regulator, like marginal bund, like guide bank, like spurs constructed over there. So all them combined together, we call them as a headworks. So Marala headworks contain Marala barrage, head regulator of the canal, and other things. So dams have storage inside it. You people being hydraulic engineer or water engineer should be knowing the difference that a dam is only the obstruction, and at the back of the dam we have the reservoir. So if somebody say a dam has 7 million acre feet storage capacity, then I say that it is not correctly statement. This statement is not placed correctly. We should say that the reservoir created because of the dam has so much capacity of water. So dam, we should tell its height, we should tell its cross-sectional dimensions, so that obstruct the water. It don't have storage within dam body itself. So, but the reservoir created on the upstream side, we can say that the Mangla reservoir has so much capacity. We should not say Mangla dam has so much capacity of the water. We can say hydropower on the Mangla dam has so much megawatt capacity. So we should differentiate between dam and reservoir and hydropower being created over there. So few figures of the storages which we have in Pakistan. For irrigation purpose, we say that we have three main storages. for irrigation purpose, we say for Indus Basin irrigation system, we have three main storages. We have many small storages, but those are providing water locally. So these three main irrigation related reservoirs are Tarbela Reservoir, Mangla Reservoir, and Chashma Reservoir. Chashma is actually a barrage, so that is the exceptional kind of barrage in Pakistan. There are about 17, 18 barrages are there in Pakistan. Chashma is exceptional that it has a small storage capacity also. Originally it was point 0.8 million acre feet, and now it has been reduced to 0.33 or 0.34 million acre feet at the moment. These Mangla and Tarbela, the upper figure is Tarbela. These are also structures built on Tarbela dam. These are spillways, and here is the spillway in working condition. And this is a plan view taken from the satellite of the Tarbela dam. What we can see, here are the two spillways. Here is the embankment or the barrier which is obstructing the flow, and it is about I think more than 100-meter high. So it has created a reservoir which is on the upstream side. This one is the reservoir gate. Here is the downstream side of this dam, and about 7-8 kilometer downstream we have constructed another barrage. We call it as a Ghazi barrage over here, that divert water to a canal. We can say Ghazi Canal, which take water to the hydropower station. We call that as a Barotha station. On the right bank of this river, this is Indus River. On the right bank of this river, this infrastructure, hopefully somebody living in Mardan, Sawabi, they know it. Near to Tarbela, they know it. यहाँ पे क्या है? Anybody? On the right bank of Indus, downstream of the Tarbela, यहाँ पे क्या है? Most of you must have heard about that. That's why I'm asking. कोई मर्दान सवाबी का कोई नहीं है? ये क्या हो सकता
सर मैं
बोलो।
सवाबी का हूँ, मैं पेशावर में रहता हूँ सर।
सवाबी का हूँ पेशावर, तो नानी अम्मा दादा अबू को नहीं मिलने जाते?
सर जाते हैं लेकिन बहुत कम जाते हैं सर। मैं बहुत कम जाता हूँ।
This one is पता होगा किसी को, GK, we call it Ghulam Ishaq Khan Institute.
Yes sir.
And so that is placed over here on the right bank. You can see while you are in the campus, I think you can see this dam also over there. And when hydropower tunnels are working, there is a good view for that tunnel. Splash of water can be seen over there. So that famous university is located on the right bank of Indus, just downstream of the Bela Dam. Here is the Google image for a diversion infrastructure for irrigation. That is the Marala Barrage. Those who are living close to Sialkot area, they must be knowing about it. Marala Barrage, just at the line of control or at the international boundary, I think it is there. Uh, the boundary between Pakistan and India is carved with the two names. One is the international boundary, which is near Lahore and Sialkot. One boundary we call it as not international boundary, we call it as a line of control. So I think line of control is over here. This part is occupied Kashmir, and over here we have the Sialkot or the Sialkot area. So water from the Chenab rivers enters into the Pakistan territory over here, and immediately when it enters into Pakistan, a barrage is constructed over here, which is called as Marala Barrage. Two main canals take off from it. We call one canal we call as UCC. You should write its name, Upper Chenab Canal, UCC, and another canal is called as MR Link Canal. When you will be studying Indus Basin irrigation system, so you will be recognizing, you have to recognize major canal systems close to your area where you are living, major canal systems which are supplying water to the areas surrounding our UET and Lahore region, and major canal system of your interest. So this Marala Barrage have some interest to for Lahore region also, because out of this MR link canal, this is MR Marala Ravi link canal. This is linking Chenab River at Marala to the Ravi River. So most of the water which you see in the Ravi River in the dry season, that is actually the Chenab water which is being diverted from Marala and being placed in Ravi River. So it joins the Ravi River upstream of Lahore. So when water is flowing in Ravi close to the Lahore area, actually that is usually MR link canal water. This second UCC canal is of interest to us at UET, Upper Chenab Canal. It is an irrigation canal. So link canal is actually diverting water from one river to other river. Usually we don't directly use it for irrigation. So it is linking water of one river to other. So from other river then we take out the canals and we use it for irrigation. So link canals are not usually linked to the farmland. They are not conveying water to the farmland. While this UCC Upper Chenab Canal taken off from Marala Barrage, so it is supplying water to the area in this doab. This doab is called as क्या कहते हैं इसको? One is Rachna, the doab between Ravi and Chenab. So that is one. This doab is called as Rachna doab. So Upper Chenab Canal feeds the upper part of the Rachna doab, but a part of after running for a few kilometers, another canal is taken off from this UCC canal at the place we call it as a Bambawala. And there is a village that is called as Bambawala. In the Google map, Google image, you can unzoom it, you can reduce its scale, and you can locate the Bambawala location. From there, a canal is taken off that is called as BRBD canal, Bambawala Ravi Bedian Dipalpur canal. So from UCC at the location of Bambawala, a canal is taken off that is called as BRBD canal. That you see when you go towards the from UET, you go towards Jallu side, you go towards border side. A big canal cross GT road, a big canal cross the canal road also. So that Lahore branch canal is being taken off from the BRBD canal close to the village of Jallu, where you have the Sozo Water Park. I think you must have gone there before Corona. During Corona, I think people are not going there. So this canal has our Marala Barrage has special link to UET because our Lahore people are getting water into the Lahore branch canal, and that is not water from neighboring Ravi river, that is coming from far lying Chenab river and being taken off. And why we are taking off the water at Marala and putting it close to Lahore? If you see in the map, Sialkot is 150 or 200 kilometer away from Lahore. So why not we directly take water from the Ravi river at Chadra? Anybody will answer this. Why we are taking water from 150, 200 kilometer away to supply water to a farm which is close to the Punjab University, which is close to the Thokar Niaz Beg. We are supplying water through this Lahore canal system. Why we are taking water from so far area? Why not directly from the Ravi? Ravi is 6-7 kilometer from the Punjab University. 6-7-8 kilometer. Why not we take out water from there? So anybody will answer this thing. What is the fun of getting water from so far place? Keeping quiet is not the option.
मे बी एलिवेशन का मसला हो रावी का.
Ravi के elevation का मसला हो. Anybody else? Roll number 16 have answered. लो जी मेरे बेटे का नाम आ गया. माज अली, open your mic. Maz. Farah Mujahid. Mars, you are not answering. So when some student don't answer, I usually kick him out of the class. So last half a minute before I remove you from the meeting. Mars चला गया सोने मुझे लगता है. Mars, okay, he is not available. I am putting him out. ये तो भेजना ही पड़ेगा. Okay, Mars, you are out now. चला गया. Okay. Who else I asked? Farah. Farah.
Yes, sir.
Have you listened my question? Can you repeat the question first?
यस सर, आपने पूछा कि हम पंजाब यूनिवर्सिटी में पानी रावी से क्यों नहीं लेते.
हाँ जी. Ravi is 7-8 kilometers away. While we are getting water from Lahore branch is taking from BRBD taking UCC is taking from Marala. Why?
Sir, no idea.
Very nice. 16 was right. Thank you for close कर दो mute कर दो अपने आप. 16 was right. One reason somebody say if he don't know anything, he can say Ravi is having shortage of water. That can be one reason. But even if it had water, because we are talking about the gravity irrigation system, this canal is gravity irrigation system. For that, 16 was right. It is linked towards the elevation of the place. For example, if we have this location at elevation of 200 meter or 216 meter from the mean sea level, so of course the supply should be higher than this. So that river is passing through a valley line. So this Ravi is passing through a valley line for this area. So valley line is the deepest point in that area. So either we construct a barrage over here and make the water level quite high, then we can divert it. And otherwise, the method is that see from where you can get water at higher elevation. So once water enter into Pakistan, that Marala, we have constructed the barrage to head up few feet of water, 10, 20, 30 feet we head up over there. And then we divert that water to the canal, and through gravity, when it reaches to this area, then we can use it for agriculture or irrigation purpose. When we take out the water from a barrage, from a river after construction of a barrage, immediately when it goes to the land area, it cannot feed that area because immediately close to the river area are higher. River is lower. We have increased the water level, although, but still the sidelines of the river are higher than the water in the canal being taken off. So usually the main canal which takes off from a barrage, it don't feed the surrounding area. It runs for several tens kilometer, hundred of kilometer. When it reaches to an area where the surrounding area is lower than that, and then it can irrigate that area. So reason is elevation. 16 was right. So as I told that the slope is required. So from the Ravi we cannot directly take up water through gravity. So that was the correct reason. So I was telling you the components. The main component required for gravity irrigation system is some kind of source of water. That source can be coming from a reservoir. It can be from a headwork or barrage. And in lift irrigation system, source will be a well or pump or tube well. In lift irrigation system, source will be the groundwater. Okay, so we move towards the next one. So another barrage, again Google Earth image. That is the largest barrage in our irrigation system. We call it as a Sakhar Barrage. 4 canals on the left bank side. You should be knowing how to designate the left bank of the river and the right bank of the river. Hopefully you know it. So river is flowing from in this picture from top to bottom, and so this is left bank canal. These are the left bank canals 1, 2, 3, and 4. Their name are written: Nara Canal, Khairpur East, Khairpur West, and Rohri Canal. On the right bank, we have the Northwest Canal, Rice Canal, and the Dadu Canal. On the right bank, after passing through Indus, through the Sindh area, some part is irrigated in Balochistan area with the barrages in Sindh. From the Guddu barrage, I think, which is the barrage upstream of this Sakhar Barrage, some area is fed to, some area of Balochistan is also fed from these barrages. So this is the largest barrage in our irrigation system, and the second last barrage on Indus River. Downstream there is one more barrage, we call it as a Kotri barrage. So here are the two big barrages, Tonsa and Jinnah barrage on Indus. Islam barrage, those who are living close to Pakpatan, close to Satluj River, Bihari side, so they might have Bahawal Nagar, they might have seen this barrage, Islam barrage. It is constructed on Satluj River. This Baloki barrage is the closest to Lahore, about 80 kilometers from Lahore. If we go towards Multan, there is a place we call it as Phul Nagar near Okada. So from there we take off, we go towards a smaller road and reach to the Baloki barrage. Usually we used to take our students to this barrage because it's the closest barrage to UET. We can come back in the evening if we start journey in the morning. So this barrage is having, Baloki barrage is having two canal on the left bank side. One they call it Baloki Suleimanki Link Canal, BS Link Canal they call it, and another canal is the Irrigation Canal, they call it LBO, not LBOD, they call it, क्या कहते हैं उसे, which goes towards Khanewal and which goes towards Sahiwal. Anybody remember this canal? Canal being taken off from Baloki. Okay, maybe next slide will having its name also. I forget it. So here is a picture of the Kotri barrage. Old name for that is the Ghulam Muhammad barrage. You can see one barrage that is not for irrigation purpose, but I have put this picture just to show you the barrage situation during the construction phase. So they construct it with the help of the RCC nowadays. They have the steel in the foundation. They have the floor, we call it as a concrete floor on the downstream side. This one is the downstream side. Here is the weir part. So we have the slope of the weir on the downstream side, and we will be having crest somewhere which is hidden from here now. There will be a top of the weir, we call it as a crest, and there will be an upstream side. So usually we provide trapezoidal weirs. So these weirs, in addition to this, there are some piers installed in it, or columns installed in it, pier or column that support the gates on it. When they will like to stop the water through the river, so they will close the gates. So those gates are supported on these piers, and these piers also support if there is a bridge at the top. So these piers will support that. If we don't have the bridge, or if we don't have the gate, we will be having only a trapezoidal kind of structure, we call it as a weir. If we want to install gates, then we have to make these walls or piers also over there. So in addition to this source or area from where we supply water, water is first given to a big canal, we call it as a main canal system. Water is coming to that main canal system, and after running a few kilometers, usually tens of the kilometer, then it divides into two or three canal system, small canals, we call them as a branch canals. And from each of the branch, there will be other small canals taking out, we call them as the distributory canals. And from each distributory, either we can supply water to the farmland or the farmers through outlets, or from a distributary, we can take out another small canal, we call it as a minor, and then minor will supply water to the farmers through the outlets. Outlets are the structures which convey water from the state-owned distributary or minor. Outlet are the structures which convey water from the state-owned. State-owned means that canal which is owned by the government. So outlet is a structure which convey water from state-owned distributary or minor to the farmer's owned water course. So in this conveyance system, we have some canals which are state-owned, which are owned by the irrigation department, which are operated by the irrigation department, which are constructed by the irrigation department. Got it? So those part are this main canal, branch canal, distributary and minor. After minor and after the outlet, the canal which is made to distribute water to different farmers, that is usually a small channel. We call that as a water course. So that is owned by the farmers themselves. That goes through the farmer land. So each farmer usually gives some land so that the water course can go through his land to feed his own land and to the downstream farmers also. So that is usually shared by all the farmers over there. They maintain that water course. So the conveyance system, it consists of two components, two parts. One owned by the state or irrigation department. By state means the province or the country or the district who is running that one. And one part of the conveyance system is owned by the farmer themselves, and that we call as a water course. Local name for this outlet is Moga. In Punjab, we call it as a Moga. Maybe in KPK, in Pashto, another name is there. If somebody can tell me, I will be thankful. And the channel which emanates from the outlet, the small channel which goes to the farmers, that is called as water course in English, but in local language we call them as khala. Khala is taking water from the outlet or moga towards the farmer's land. So this conveyance system is necessary. We have this conveyance system which is running on gravity. Most of our conveyance system is unlined. Most of our conveyance system in Indus Basin irrigation system is unlined. Slowly we are shifting towards the lined conveyance system. A lined conveyance system means the surface of the canal is lined with concrete or some other impermeable material. Usually we use concrete or bricks to line it for its structural stability and for reducing the seepage. Main purpose is these two things, reducing the seepage and for structural stability of the banks of the canal. Most of our canal are unlined, so we are incurring, we are facing with a huge loss through seepage. There were some studies carried out by WAPDA and Irrigation Department. They say that if 100 unit of the water is diverted to the canal conveyance system, only 40% to 50% reaches to the farmland. Rest 50% is lost in seepage and in through evaporation. Evaporation have 5-10% losses. Mostly it goes towards the seepage in that area because of our old and unlined canal irrigation system. So then as we are facing with the water stress, we are shifting towards the line canal system. Now new canals are constructed, are not constructed without lining, they are constructed with lining. One example is the Chashma Right Bank Canal in DG Khan, DI Khan area. We call it as a CRBC canal, that is lined canal. I think recently Jalalpur Canal have been constructed close to the Mandi Bahauddin or Rasool on the right bank of the Jhelum River. So that is also what we call it lined canal. And this canal system, which we call your Lahore branch canal, it is partly lined. This is partly lined. If you go over there when it is dry, you can see the sides are lined with the bricks. So it is partly lined. Bed is not lined. Bed is alluvial bed or sandy bed. Sides are lined. BRBD is, I think, I don't remember it, whether it is lined or not. Okay. So you are now familiar with the conveyance system. By conveyance system, we mean main canal, branch canal, distributary, minors, and water courses. Then we have to show you some picture of this conveyance system. Here is a picture of Chashma right bank canal, and you can see the panels of lining. Concrete is placed in panels so that the shrinkage and expansion can be accommodated. Concrete is having high shrinkage and expansion because of the change of temperature in the area. It expands, and change of temperature also causes it to shrink. If we don't provide these construction joint or expansion joint, it will crack haphazardly. Within these joints, we put some water sealant or water stopper so that water should not penetrate through it, but it has the capacity to expand and shrink. Uh, at the suitable places, we give access to the people for getting water out of the canal or for using water for their daily use purpose. Here is a picture of a distributary, which is unlined canal running through an area. From the size, I can say it comes either, it seems to be a minor canal over there. Here is the water course, and seems to be a lined water course which is going into in a farmland over there. On the both side there are the agriculture field over there. From the water course, water is applied to the field with the help of a structure which we call as turnout. In local language we call that as a nakka. Previously we did not had such a concrete structure over there. Previously, when water courses were unlined, when the water courses were only the earthen channel was there, made of simply soil. When concrete lined water courses were not there, then people used to get water out of the water course just by cutting the bank. They used to cut the bank and get the water, and when a field was sufficiently soaked, then they close that bank with the help of putting soil over there again. But now, when the water course is lined, so then they have made the concrete structures with an opening inside it, and that opening can be closed with the help of this cover-like structure, manhole cover-like thing, plate over there, which can be removed and which can be placed over there. If they want water, they remove this cover plate and the water goes into the field. And if they want that water should go downstream side, this is placed again. The distribution system mainly is done, distribution of the water is mainly done with a system we call as a Varabandi in Pakistan and India. And Varabandi is, this is the local name, Varabandi. We call in English, we can say it as a rotational allocation of water, rotational system of water allocation at the water course level, at the water course level. So we have a Varabandi schedule or a rotational schedule at each water course. Usually one water course supply water to 50 square area. In Pakistan, area is measured in units. We call them, the big units are murabba. In English, we call that as a square. And smaller than that, we have acres. Smaller than that, we have canals. Smaller than that, we have marla. So you should be familiar with this. I think the lab teacher will be telling you how big is the size of a marla in agriculture system. A marla in urban environment, in LDA environment, is 225 square foot, while marla in agriculture or in irrigation environment is 272 square feet. There are 20 marlas in a canal. There are 8 canals in 1 acre. There are 25 acres in 1 square or 1 murabba. So in this way you can see. So the whole agriculture area has been divided into these units: murabba, acres, canals, and marlas, and they know that who is owning which land. So they call it as their land allocation, and they are making it digital nowadays. So Varabandi is the system of distribution of the water on rotational basis to the farmer of one water course. Usually they sit together and they allocate the water, they allocate the hours of available to each farmers. This rotational or Varabandi irrigation system is run on 10 daily basis or 7 daily basis. So they see how many hours are there in 10 days. They see how much is the land which have to be served by this one water course. Then they divide the hours or minutes for a unit area of the land, considering the time required for filling of the water course and emptying of the water course. That is also counted. There will be one lecture or a half a lecture in which we will be giving you, we will be telling you how to carry out Varabandi for one water course. At the moment, you should know that we use the system of Varabandi for allocation of the water. And it has the benefit, this Varabandi system has the benefit that each farmer gets allocation of the time of the water course as per his ownership of the land over there. If he is a big land ownership, he will be getting more hours out of the total hours available. And if he has smaller land ownership, so he will be getting proportionally smaller time period. It has some positive things also. We divide the water based upon the area to be fed, and it has some negative things that if due to certain reason canal is closed when it is my time to use water, if the canal is closed, so my turn will be lost. It will not be, this is not the rule that I will be compensated for that loss. So that happens with all of the farmers at some time, so people accept this problem also. So Varabandi is the rotational method for equitable distribution of available water in an irrigation system by turns. Turn by turn, each farmer get the water, and that turn is decided in this schedule of allocation. People specify that before hand, they specify that from 8 a.m. on first day of the Varabandi, from 8 a.m. to 10 a.m. This time is for farmer number one, farmer number two, farmer number three. All that area which is fed by one water course, all that area which is fed by one outlet. Outlet gives water to water course. Outlet gives water to one water course. So all the area which is commanded by or which is fed by or which is served by one water course or one outlet, so that area in Punjab environment is called as chak. So we have chak bandi in our agriculture system. So each area is given a certain number, chak number 120 ml, check number filana GB Chang branch or something like that. So check number are very famous as the address is also Mr. Filana, check number Filana and area Filana. So that is related to this irrigation system. One outlet, outlet will be having a certain number. Each outlet is given a certain number. So area which is fed by that outlet, that is called with respect to that outlet number, and we say this is the check number Filana. So that is also linking you to the local terminology, local utilization. So application of the water is also part of this irrigation system. Different method of application of the water have been utilized in gravity irrigation system. We use this surface irrigation system. Flooding, furrow method are usually utilized in gravity irrigation system. If we have the lift irrigation or the pump irrigation system, then we use this sprinkler, and another type of the pump irrigation system is called as उसको क्या कहते हैं drip irrigation system. So one of this way of application of the water to the field will be there. Once water is have reached to the farmland, so usually we use this flooding method or furrow method to apply water to the plant itself. If we are having a gravity irrigation system, we have the pump installed over there and we have supplied water to the field, then it can be applied with the help of the flooding or furrow method, or we can continue that pipe and we can supply water to the sprinklers over there, and that becomes a sprinkler irrigation system. Or we can supply water to the pipe system which have the small opening inside it, like a small meters or small openings which provide water drop by drop to the area surrounding us, each plant. So that system is called then as a drip irrigation system. When we supply water to the area or the root zone surrounding a plant in the form of a drip by drip, we say that this is a drip irrigation system. With respect to utilization of the water, with respect to the efficiency of application of the water, this drip irrigation is considered most efficient method in all other application methods. More than 90% of the application efficiency we achieve. Application efficiency is defined in such a way that if we provide a certain quantity of the water to the field, how much quantity out of that is utilized by the plant itself. Some quantity of the water is percolated deep underneath, some is evaporated, some is drained out of that area, so that reduces the efficiency of application. So those application method which gives maximum water to the crop and least loss to the percolation, to the evaporation, to the drainage system, so that method is considered most efficient. So if we want to calculate the application efficiency, we measure how much is the water used by the crop or the plant out of the water supplied to the field. So when we divide these two things together, we get the ratio, we call that as application efficiency. So this drip irrigation system is considered to be most efficient, and more than 90% efficiency can be achieved with the drip irrigation, and about 70, 80 or more than 80% efficiency we can achieve with the help of the sprinkler irrigation system. And furrow irrigation system also reaches to 60-70% efficiency. Least efficient is this flooding method. We open the channel into a field, and that field is flooded freely. So that is a free flooding. So that causes more evaporation, that causes more percolation, that causes more losses, and we achieve less efficiency. But it is the least labor cost method of application of the water. So we started from the infrastructure which we need, and now we are telling you a way of application in an irrigation system, and rules of allocation of the irrigation system. That way of application and the rules, that will come under the component of method of distribution and application of irrigation water. Sometimes land area is of such way that we have the slopy area for agriculture over there. This method is usually utilized. We call it as a contour plantation. We make the terraces, we make the step by step, we make the small field at the same level. Then next field is made another level, next field is made another level. And usually we don't have irrigation in this area. Gravity irrigation is not used over here. Sometimes it is the natural rain-fed agriculture is done over here, or sometimes we use sprinkler irrigation system over here. So most of the time on the hilly area, we don't need the irrigation system. Rainfall is sufficient over there. But if some place have got the good groundwater over there, they can use the pump system and sprinkler system to irrigate this area. So these are some of the ways of application of the water. Sprinkler are shown over here. A kind of sprinkler we call is as a pivotal irrigation system. A large boom, which you cannot see directly over here. So this line is showing a truss over there. In civil engineering, you know what is a truss. We can call it as a boom also. So it is supported at the center like a pivot arrangement. It can rotate around this. That truss have wheels at suitable locations. So these circles are showing the places at which the wheels of this truss are rotating. So at the center, it is rotating at a central point. We call it as a pivot point. And from the center, it is supplied with the water also. So there will be a pump which will be supplying water. So this truss is carrying the pipeline or the hose which are connected with the sprinklers or emitter at the suitable location. So this truss on the wheels, it rotates continuously, supplied with the water at the center. Water emits from the sprinklers, and as it rotates, so it feeds the water to this circular area. And this, if we see from the satellite, we see some pictures like this in an area which is fed through the pivotal irrigation system or pivotal sprinkler irrigation system over there. This is the picture in Saudi Arabia, the desert area. They are feeding with the because they have shortage of water, they are using this sprinkler irrigation system, and out of the sprinkler irrigation system, specifically pivotal irrigation system they are using, and they are getting some landscape which is very odd as compared to the landscape we see in the other area. Background is sandy, but wherever they have got the water, so they have changed the land use to the green area over there. Drainage system we need to evacuate the excess water. If that is not evacuated, we will be having condition as it is shown on the left hand side. Water will be standing in the root zone or above the groundwater level. So such area will be called as a water log if this standing water sustain over there for a longer period. So we will be not getting some suitable crop from that waterlogged area. So we have to provide either drainage ditches or drainage drains we have to provide on the surface, which we call as a surface drainage system, or we have to provide a subsurface drainage system, which we call as a tile drain. So this subsurface drainage system usually has perforated pipes laid under the ground level. We lay them 4, 5, 6 feet below the ground, and it has perforation inside it. So on the water table which have risen to a higher level, if we see the cross section over there, we have not showing you over here the tile drainage system. This is a surface drainage system. How does it help lower the water level? If originally water level was over here, when a drain is provided over there and its level is lower, so this groundwater will be seeped into this drainage system, and this drain will take away that water to a bigger drain, and that bigger drain will be taking water to the river, and ultimately it can be taken to the outside of that area. Or if its quality is good, this drain can collect that water into a sump, and we can reuse that water. Instead of surface drains, if we close this one, and if I provide a tile drain over here, a pipe, and that has perforation or opening inside that pipe, and we cover that pipe with some good filter material so that those perforations should not be clogged or should not be stopped, then similar kind of action will be there. A higher groundwater table will put water in that perforated pipe, and then that perforated pipe will take away that water to the sump or some other area. So either a tile drainage system we can use. So you should understand the difference between surface drainage system and the tile drainage system. Surface drainage systems are open to environment. They are like open channels, while tile drainage systems have pipes which are not visible to the people over there. They are running underneath the ground, and they are taking water away from that area in an efficient manner. Benefit of that is we don't lose land from the agriculture activity. Those drains are underneath, and we can carry out the agriculture activity at the top. Of course, cost of the tile drainage system is larger as compared to the cost of the surface drainage system.
Excuse me, sir.
जी
सर जब पाइप्स हम ले करते हैं किस जोन में करते हैं, रूट जोन से नीचे या
we decide that at which level we want to keep the groundwater level. So usually there will be a cone of depression constructed For example, if I want that the water level, groundwater level should not go, should be, for example, if the ground level is at 0, and I want that the root zone should be kept dry. So if we say root zone is at 5 feet, so then we will be keeping this tile drain 1 or 2 feet below that 5 feet level, so that water level at groundwater table level should not go beyond 5 feet. So when it goes beyond 5 feet, so then tile drain get water, and that water can be evacuated from that area. So proper design is carried out, seeing the permeability of the soil, seeing the conductivity of the soil, then the level is decided below the level at which we want to keep the groundwater table level. Got it? So if it will be below that
Yes,
water
sir.
level which we want to sustain, then it will get water. So it has a linkage with the level which we want to maintain over there. Okay, I stop it. It is 9:23. I stop it for 5 minutes or 3 minutes to give myself a rest, and then we will talk about the water quality parameters in an irrigation system in an agriculture environment. We will not be talking about the water quality standards for drinking purpose. That you might be studying in the environmental engineering. What are the water quality standards for drinking purpose? We will be telling you the water quality standard required for agriculture purpose, and how much area is underlain with the which kind of groundwater quality, and what are the units which we use to measure the water quality. So 10-20 minutes we will be talking about this thing, and I take 5-minute break. I will come back at 9:30. You can also move around and take a 5-minute break. I also stop the lecture recording so that the file should be small.